All right, can you hear me now? So this talk is about distilling the web. And if you're here to listen about distilling whiskey, that's a different venue, probably around 5:30 downstairs, I heard. So I kind of call it distilling the web because this is kind of like distilling water or distilling anything or filtering. We CDNs are kind of like in the middle pathway between where the audience is and where the origin is, right? So we kind of have a way to kind of filter kind of stuff that you don't want to go toward the origin, right? So the multi-layer filtering that we can apply inside CDN. So I'm going to have to use my own our CDN, Edgecast Verizon, as an example, but that's pretty much how the CDNs have evolved from just being the static content delivery to the application delivery networks, along with the security and other value-added services on top of it. And I'm calling it distilling the web because kind of like that, for our partner, Distil Networks, our business partner, Charlie is here, so he'll be co-presenting this with me. So kind of like a prop to their name as well. So I want to start with like, what would you do type of scenario, right? And after that, I can kind of go through some of the scenarios that we have seen in operating, this Edgecast CDN for almost more than 10 years now. So let's see that, you got a ransom node. Maybe many of you read it in the news that a lot of ransom nodes going on these days with the ransomware and, encrypting files on your computers, that kind of stuff. But this is not about that. It's similar to that in that, you may get a ransom note asking to pay some Bitcoins, and if you don't pay up, they're going to attack you and take down your website by a certain date or certain time. And so I'll kind of discuss one of the scenarios that we went through in dealing with this issue. And also, how about this? You started to see a lot of this this type of messages in your log files, or your web server started to get start acting funny and so on. And this is actually the breakage of the framework called the Struct2, the Apache Java-based framework. And when that breakage came out, so this is actually the proof of concept code that someone released. And when you start to see things like cat Etsy password in the logs, that cannot be good, right? So no one should be asking your Etsy password file either through the CDN or directly. And how about this, right? You probably heard this news like maybe 3 years ago, or this has your business has nothing to do with them, but they lost some of their username and password credentials, right? So what would you do? How could it affect you? Like someone out there, nothing to do with your business, losing their customers' data. How could it affect you? And then we're going to talk about that and how we can provide a solution inside the CDN space. So to make a little more sense of that, this is at least in our CDN. This is how Edgecast kind of filters different type of content across our CDN, right? So on the left is the end user, and on the right end is the origin server, right? As the traffic crosses from left side to the right side, we do layers and layers of filtering to kind of stop that unwanted traffic that you define. And unwanted traffic can be anything. It could be downright malicious, or it could be even just based on policy that I don't want to do business in certain countries or like that. You can define these policies and so on. So yeah, DDoS is here. Along with ransomware, DDoS probably is the other headline that you will see every now and then. So this is based on a true story. We are based in LA. Our marketing guys kind of also want to be script writers for that other industry that we have in LA. So this is kind of going to be told as as a documentary story. But what's good thing about this is that there has all these actors like all the villains and victims and Bitcoins and ransom and also international criminal gangs and so on, right? So to cut a long story short, this about a couple of years ago, right before the busy shopping season in October, one of our customers, they are a global e-commerce company, and they got this note from a source that claimed to be from Russia, because it says like mail.ru as a domain name where it came from. And they sent this note to multiple people inside the company, like, hey, make sure you forward this to your security department or security team because, we're going to attack you. And this is who we are, and they said their name and also like, hey, let me Google it for you. Like, if you don't know who we are, go look at these Google links. And what they said is like, we're going to attack you. We're going to attack you by certain date and time, and this is the volume that we're going to attack you with. And if you don't pay up by that date, we're going to keep attacking you until, you pay up or, your cost will go up, every other day and so on. And they also said that, oh, by the way, we attack you, we send you an attack at this certain time and date just as a proof of concept. Right, so they got this email and the next day, they call us, right? So luckily, they have this ongoing security, managed security relationship with us. So they call us, and I remember that day, they make sure that Tin is on the phone and, your whole security team is on the phone because, our security team is on the phone and we want to discuss about it. Wow, that's exciting, right? So basically, they call us, Verizon, we have a problem, So for this, and almost all, major DDoS cases, we put all hands on deck. That means that, not just security and account management, but also, our network engineering, network operations center, and so on, right? And we took a look at their vulnerabilities, and we took a look at the attack surface, meaning that, where in the, CDN, the chain of flow that it can be attacked is exposed. So we put a plan in place, and then we activated that. And the hardest part of the plan came, right? That's waiting. So we waited, and day 3, we expected an attack, but attack didn't come. Day 4, 5, 6, and so on, right? So after about a week, we are like this, right? So are you going to attack us or not? And while we were waiting there, we also went back and looked at that, the proof of concept that they sent, right? We look at their logs and stuff, but to tell you the truth, nothing really registered as an attack for us, at that time and hour that they mentioned. It could be one of few things. One is that, they just bluffed, right? They said they will attack, but they never really sent that attack. Or it could also have been that they did attack, but, attack is such a small amount that it, based on, compared to our massive volume of traffic and the transactions that are going on across our CDN, that just doesn't strike us as an anomaly. Well, on day 7, they attacked us, right? So we're based in LA, so California time around 6:40, we started to notice a very large and fast. And large and fast are two different dimensions on measuring DDoS. So we noticed that very large, but more noticeably very fast Syn Flood attacks, right? So any of you not familiar with Syn Flood, don't be shy. It's always first time hearing something about Syn Flood. So when you make the TCP connection to the website, because the web runs on HTTP, which runs on TCP, right? So the first thing you do is that you send a packet called Syn, right? And the server will allocate some resources on its side, and it's going to send back like, oh, Syn ACK, okay, I hear you, and I say hello back to you, and let's complete this 3-way handshake, right? And what happens in a normal scenario is that the client will send something back like, okay, this is good. Here's my Syn ACK, final ACK back, and then let's start talking. But when an attacker wants to attack, what they do is like, oh, Syn, I want to talk to you. But they never complete the initial handshake. So what the server has to do is the server has to keep a lot of resources on its side just to see that, oh, in case they come back and talk to me, that I have something ready to talk to them, right? And when they do that in massive volume, what happens is that it exhausts these resources on the server, and the server cannot accept these legitimate requests anymore. So this is what it looks like from our point of view. We see spikes and we analyze them, right? And short version of the story is, we found this and we kind of, mitigated with the minutes. But actually, how we were able to do that is because of this, because of our design, right? So we use Anycast. A lot of modern CDNs use Anycast for routing. What that does is that it spreads a load, whether it's legitimate load or illegitimate load across our CDN. We use super POP so we can put more machines at the more strategic locations, so we have more compute power at each of our POPs. And we use both network level DDoS mitigation and the web application firewall because a lot of attacks are blended in nature. So for those of you not familiar with Anycast 101, you get same IP address when you do the DNS resolution. And where is that IP address? Well, it could be anywhere on our network, right? So depending on the routing conditions and our load, that IP address could be anywhere in Seattle or New York or Boston or LA or San Jose, right? And then combine that with the massive capacity that we have, we can do the volume of these attacks pretty well. We can handle it, right? Because our CDN is most of the time pushing out the content, so there's a lot of bandwidth left to absorb, the volumetric, the kind of things that you hear about, like how many gigabit per second type of attacks. And also in looking a little deeper into this, right? So we have this our own system called the Stonefish. What it does is it samples the packets out of the routers and what we call the directors. These are both load balancing machines and also attack detection machines. And when it detects something like an attack, it can analyze these packets and what you might call machine learning today, but we've been doing that for like 10 years. So it's like it started as like indexing on the right field and searching and sorting and searching for the right attributes, and it'll also send out these signatures out there onto the edge. So a few lessons that we learned from this, right? So one is to have a plan. Just having the relationship, before something happened, and knowing, having your staff educated to what to do when you get a ransom note like that is really a big deal. And protect your origin, right? So if you remember the little data flow that I showed earlier, right before you get to the origin, you have a router on your on-premise, or it could be some configuration in the cloud. What we recommend you do is to blacklist the entire internet, but only whitelist your content CDN provider or the cloud provider. And don't forget your Apex domain, because Apex domain is something that without www, and we kind of learned through our experience that if you don't do the Apex, you map the Apex domain to the CDN, you'll have the origin open because you have to for some customers like that who type in not without www. You need on-demand security and capacity because you alone, as a regular company, you cannot have all these bandwidth and stuff. And you need some agile service who can augment your security staff. And I also kind of want to leave you with a bit of food for thought, if you will. So on the right is our total capacity, and 1 terabit per second is both a national televised events, like something like Oscars or Grammys and stuff, ESPN shows that we do on a regular basis. The biggest one we have done is a college football final on the upward of 3 terabit per second, right? And that's also the biggest DDoS that was ever claimed to be, right? But the average DDoS, based on the data that we analyzed from Verizon Data Breach Investigation Report, is about 5 gigabit per second, right? So compare that to the on-premise device that you can afford, which usually around 500 megabit per second. Can you really do that on your own? Another way to look at it is your attacker is not going to use one machine to attack you. They're going to use botnet or botnets to attack you, and you need something like a distributed and high capacity infrastructure like a CDN to sit in front of you. The other part is our web application firewall, but in the interest of time, I'm going to skip. But to cut the long story short, we have web application firewall integrated to our web server. That kind of gives you a second layer of defense against attempts or against either known or unknown vulnerabilities that you may have. And with that, I'm going to hand that over to Charlie, who's going to skip a few more slides and talk about how we do how we deal with bot traffic that we've been increasingly seeing.
Thanks, Tin. So at Distil Networks, if you think about DOS, right? So that's sort of the first layer, the volumetric type attacks, and then the WAF is a set of rule sets. It's primarily still IP-centric security, rule sets and such that need to be maintained and such. And what Distil's focused on are the bots that get through those first two layers. kind of think of it as layer 7 security, or application security. And what you find is once you've gone through the DDoS and the typical WAF protections, there's still on average around 20% of the traffic that's coming to most websites is actually not traffic you want. It's malicious bot traffic. It's not humans, it's not the good bots, it's bad bots. And the reason people do this, the reason you have this traffic is because people are making money. Right? I mean, there are over 135 services that we've detected, commercial services that are being sold on the internet to do this type of work. And you can go find people on Odesk or other websites that offer freelancers. It's very inexpensive to find people to scrape your websites. So what are they doing? So they're doing web scraping. So that's stealing content, pulling down prices. So for retailers, pricing strategies and things like that. There's security breaches. They're filling in forms for lead gen, or they're putting in spammy links into forums. They're filling in free registrations. They're testing credit cards at scale. They're screwing up marketing analytics so that you can't tell, how do we optimize our site if 30% of the data we're analyzing is actually just bot traffic, right? Hard to do A/B testing with any accuracy. Downtime. So we call it application DOS, right? So there are certain queries which are not volumetric, but can basically crush an application. So an example of that would be one customer of ours has a great tool. They have this e-commerce database. It's indexed only for 4 or 5 parameters, and they get these queries with 200 parameters asking for page 501. And basically the back-end databases that are supporting and serving up all the content are crashing. Not a volumetric attack, very sophisticated, asking the right questions, knowing the database behind there. And that's what they're paid to do. There's also aspects of digital ad fraud where people are either maliciously creating synthetic audiences, going to all sorts of premium publisher sites to get cookied and then selling that audience on an ad network. Or in some cases, it might be retailers who are sending out bots to click on competitor ads to use up or mislead their marketing spend. We've seen scrapers that scrape advertisers off of real estate websites, and then they go create a marketing list off of somebody else's advertisers. So all sorts of nefarious things. And then, of course, the latest thing is API abuses, right? So everybody wants to enable their partners, or maybe you're moving to a single page app. There's a lot of API that are exposing your web servers and application servers, and those are typically not very well secured. So what kind of websites? Well, they're pretty typical attributes for most websites that are trying to be commercial, right? There's pricing information or proprietary content, which is why consumers come to the website. There might be some web forms because of when they come to the website, of course, you want to capture some information about the people who are coming there. Maybe they'll become customers and pay you some money. Once they're a customer, they might want to sign up, or they might want to log in, manage their account. Often we'd like to collect payment through the website. So these are all really attractive things that people have on a website. And by the way, there is advertising on websites sometimes. So for all these different reasons, which are all just very common things that you see on a commercial website, these are all very attractive things because people can make money off of it. So what kind of websites, or how often? Well, for sites with retractive content, 97 out of 100 of them are getting some scraper traffic. For websites with forums and such, around 30% of them are getting a lot of bot traffic. Interesting thing is on the logins, 96 out of 100 sites that we look at that have login pages do get bot traffic to the login path. And then it gets actually a little bit worse. Behind the login, it's actually 90 out of 100. So still the login is kind of one of those things, and I want to talk about this for a second. Most people think, well, Charlie, we have a login, all our content's protected. Well, actually, for sites that have a login page, we see fully 3/4 of the bot traffic is actually after someone's logged in. And speaking from experience with some content providers and people with proprietary databases and such, I can assure you we've seen as high as 40 or 50% of all the traffic behind the login is actually bad bots. So once you get through that login, it's very attractive because that's where the goods are, right? So there's a lot of traffic of bots actually behind the login page. Might be a little bit counterintuitive. Maybe you think the login page is really protecting you, but not really. So, why is this such a difficult problem? Well, because the internet's growing, and as we've talked about, right, it's hyperscale, there's all these virtualized resources, it's so easy now and so inexpensive to spin up resources to create a scraper and a bot, right? So because of that, it's also easy to change IP addresses. So bots are really sophisticated. They're going to switch their user agent and IP address the majority of the time. So we see typically 73% of each bot we find is switching its IP address frequently. And now they're getting more sophisticated, so they're trying to mimic human behavior. They're not doing really obvious stuff. They're trying to simulate how a human interacts with the website. And indeed, they're using Selenium and other tools that were actually developed to test a website, and they're now using those for nefarious purposes to go and exploit competitor websites. On top of that, 53% of the bots are now executing JavaScript. So they really do look like a human because most of our sites now require JavaScript, so the bots are executing JavaScript. Again, they want to look human. And of course, a fair amount of it is also still in data centers, in addition to the botnets. So how do we deal with that, right? So that's a complicated problem. It's affecting all sorts of the commercial reasons that we actually run websites. So the core of it for us is really you have to be able to protect the whole website, and you have to be able to protect all access to the web servers. That actually includes native mobile apps, APIs for partners, single page apps, all the different ways that we provide access to the web server. And the second thing is you really have to rely on an accurate fingerprint. So you got to go beyond the IP address, you got to go beyond the user agent, and really compose what is a very comprehensive fingerprint. So we call it a high-def fingerprint because for our fingerprinting, we use over 200 different attributes. And we're an inline solution, which means we're going to interact with the browser. So since we interact with the browser, a couple important things with that, right? We can actually make our service tamper-proof. We can vary what we do and how we interact with the browser. So if we sense that we've been detected, we're going to use the same evasive tactics that a bot might use so that we can hide from the bot operators so they won't realize we've detected them. So the other thing is, as a security play, we have all sorts of tactics that we're going to use to detect a bot. We're not relying on one thing. So we do browser validation tests, and with the fingerprint, of course, we have a database. We have about 100 billion fingerprints in the database from the last 5 or so years of operations. So we share that. If we detect it on one website, we share it with another. So if we find it on StubHub, we can share it with Hanio. And the same thing. So we've created a community where we share that information automatically across the network, all the websites that we protect. We also use machine learning. And so machine learning, we're going to actually look at traffic to a website, and we're going to analyze the behavior of what a human does on a website. And then using Capture or other tools, we're going to identify suspicious traffic, and we're going to test that. And through that, we're going to learn on the domain what the behavioral model looks like. We're also going to look across our network and see if we've seen that suspicious fingerprint behave oddly on other websites. So we have a network-wide machine learning going on as well as a domain-specific learning going on. And then, of course, it's always important to give the application owner, the business, all sorts of options. So we try to provide a very flexible response. We allow them to block, CAPTCHA, monitor. We have a lot of customers who like to serve back different content when they suspect a bot. Okay? Because this is security, at the end of the day, we know you can never be at 100%. So we actually have an analyst team as well, which if we haven't caught it through all our automated tactics, we have humans who will go through the logs and work with your team. And that's where we start to integrate, and this is where it really becomes a security operation, where we integrate with the security operations center of the business that we're supporting. And that way, the analyst managed services really help get you to that nth degree. So if having 0.1% of your traffic hit the login with automation, maybe that's okay. But if 0.1% is 10 million page hits, like maybe that's not okay. You don't want people testing, logins with 10 million hits. So those are the things that the analyst managed services can do, and that's where we really develop a partnership with the business that we're protecting and the website. But let our customers speak for themselves. For a lot of companies, they've thought of this as something they need to do for themselves. It's something they can do in-house. And for companies like Lamudi and White Pages, both of them saw huge decreases in the resources that they're allocating to protect their websites. 30 hours a week. And 20% of their DevOps from White Pages. And they also had some customer care issues as well because they were using IP addresses and blocking a lot of humans. For StubHub, actually, they had a huge reduction in their page views. So for them, that was a huge boon. Even though they're a retailer, they saw it as hugely beneficial to their business to be able to block all that malicious traffic. So we're open for questions now. Just a few of the other logos who we work with. Primarily, the companies that have really premium content or have very dynamic pricing have been some of our best customers. So
any questions?
Open to any questions.
Yes.
A little more how you cleanse the data, like for instance, do you use scrubbing centers, or how do you do that?
The scrubbing center, if you call it scrubbing center, is kind of built into our POPs. So we have filtering mechanisms to learn the packet behavior and filter it based on the attributes that we don't like. Sure. Any other questions? Yes.
So do you have any sort of a concept of what is too much? Like you could put so much security on the front end of your website that people would really have a really hard time getting in. Does that damage the benevolent customer's interest in using your customer's sites?
Yeah. So the question is, what is too much? When does it become too much security? In that, it's going to cause, what we call the false positives, right? Identifying someone normal as bad. So that threshold, that how you dial up or down that parameter depends on, usually on the customer, the individual company's attitude toward that, and also on the industry, right? So for example, for e-commerce companies, they would rather have that on the loser side, in that they would rather let some of the attacks in or go through the CDN, or they'll deal with it later than block some legitimate traffic, right? It may be different on the media publisher, especially when one publishes controversial content or someone that might upset some people. They might want to have any on all attacks or that look like attack, just stop at the gate.
So first, we have a number of different settings you can use, and we measure, and can monitor, obviously, any false positives. So it's something we typically are constantly optimizing, depending on what's going on our website. But yeah, I mean, for e-commerce sites, these guys are not very forgiving if they think we're having false positives. So, and it's invisible too, so it avoids the CAPTCHA or any other user interactions.
Any other? Almost lunchtime.
Yeah. Got one more speaker to go.
All right, thanks so much. Appreciate your
Thank you.
attendance.